In this episode in the Explaining the Hard to Understand Stuff series, we're looking at how stars and planets form. Or as I like to call it, how cosmic dust has its life together better than most of us. Let's explore this. Hello there, welcome back to Star Stuff, where we look at the universe's most complicated ideas and explain them in a way that won't make your brain want to quietly pack its bags and leave. Before stars, before planets, before the one guy in the comments who always says, "This is fake," there were nebulae. A nebula is basically a massive cloud of gas and dust floating in space. These aren't little puffs. We're talking tens to hundreds of light years wide. Inside these clouds, about 90% is hydrogen, a bit of helium, and tiny traces of heavier elements, the seasoning of the universe. So these clouds are mostly made up of hydrogen, which is the simplest, most common element in the universe, which is convenient because hydrogen is basically the Lego brick of stars. So some regions are called molecular clouds, where atoms combine into molecules, and these are the real star factories. So what turns a lazy space cloud into a star? Enter gravity. At some point, something nudges the nebula, a nearby supernova explosion, a passing star, or just gravity being gravity. This causes parts of the cloud to become slightly denser. The region begins to collapse inward under its own gravity. As it collapses, it spins faster, which is also called the conservation of angular momentum. It flattens into a rotating disk, and the center gets hotter and denser. This spinning motion is why solar systems look like cosmic pancakes instead of cosmic meatballs. Gravity doesn't negotiate. It's like, you will come together. Emotionally or physically, I don't care. At the center of this collapsing cloud, a protostar forms. Think of it as a glowing ball of hot gas, surrounded by a swirling disk, still collecting material like it's in a space-themed shopping spree. As more gas falls in, the pressure increases, the temperature skyrockets, and the core becomes insanely dense. You also get jets of material blasting out from the poles, like the protostar is aggressively announcing its existence. Eventually, the core reaches about 10 million degrees Celsius. That's when physics flips a switch, and nuclear fusion begins. Hydrogen nuclei fuse into helium, releasing energy according to the principle behind nuclear fusion. This creates outward pressure that balances gravity. Boom! You now have a stable main sequence star. So you could say that a protostar is basically a star going through puberty. Now let's talk about everything that didn't make it into the star. That leftover material forms a protoplanetary disk. Inside this disk, something surprisingly delicate happens. Here's a step-by-step to planet building. First, microscopic dust grains collide. Then electrostatic forces make them stick, like static cling. They grow into pebbles. Then those pebbles form rocks. Those rocks become planetesimals, which are kilometer-sized bodies. And then gravity takes over again, and larger bodies are formed. This process is called accretion, which is basically cosmic snowballing. But it's not smooth. Collisions are frequent. Some objects shatter, some merge. It's less peaceful formation and more space demolition derby. Planets didn't gently form. They fought for their lives and won. Here's where distance from the star changes everything. The inner region, which is close to the star, is very hot. Only metals and rocks can survive, and they form terrestrial planets, like Earth. Then you get the outer region, which is beyond the frost line, which is cold enough for ices, which is water, methane, ammonia. There's more material available, which forms massive cores that pulls gas in and creates gas giants. So Jupiter didn't just decide to be extra. It had better building materials. So the inner solar system is like, we made rocks. And the outer solar system is like, we have a gas empire. So early planetary systems are not calm at all. Planets migrate inward and outward. Gravitational interactions fling objects, and massive collisions reshape worlds. Our moon, for example, was likely formed from a collision called the giant impact hypothesis. A Mars-sized object slammed into early Earth, ejecting debris that eventually formed our moon. So yes, the moon is basically Earth's crash aftermath. Okay, let's look at why all of this matters. Every heavy element in your body, carbon, oxygen, iron, was created inside stars through fusion or supernova explosions. This idea was popularized by Carl Sagan, who famously said we are made of star stuff. Now, as nice as that sounds, he wasn't being poetic. He was being accurate. So when you look at the night sky, you're not just looking at stars. You're looking at your origin story. What's funny is you're made of ancient star material, yet you still forget why you walked into a room. And that's how the universe built stars, planets, solar systems, and eventually you. From a cloud of gas to conscious beings wondering about their place in it all. So remember, the universe isn't just out there. It's in you. Thank you so much for watching. If you enjoyed this video, please like and subscribe. And if you'd like to support the channel further, you can join to become a member. And if you have something to say, I'm here to listen. And by listen, I mean read all your comments. Cool beans.